Okay, so imagine a world where, like, all our online secrets could be, like, cracked open in minutes.
Yeah.
That's the kind of threat we're talking about today with Shor's algorithm.
Right.
We're diving deep into it today.
Right.
We've got this essay by Jörg-Owe, who really kind of brings the urgency of this whole issue to light.
Yeah, it's a big one. And what's so fascinating about this algorithm is it leverages the power of quantum computing.
Right.
To do something that seems pretty simple on the surface. It factors large numbers,
Okay.
but it does it exponentially faster than any classical computer.
Wow.
And this ability could totally shatter the foundation of modern encryption.
Yeah.
Like RSA encryption.
Right. Yeah.
Which relies on the difficulty of factoring those large numbers.
So it's like, if I'm understanding this correctly, it's like having this master key that can unlock any door just by quickly finding its prime factors.
Exactly. It's a great analogy.
And so Jörg-Owe is basically waving a big red flag here saying we need to change the locks.
Yeah, absolutely. He's saying, look, organizations need to start transitioning to quantum-safe cryptographic methods now.
Like yesterday.
Yeah, he paints a really vivid picture of what could happen if we don't act soon.
Okay, so let's rewind a bit for our listener and give them some context here.
Sure.
This whole concept isn't exactly brand new, is it?
No, not really. It goes back to 1994.
Okay.
When this mathematician, Peter Shor, first proposed this algorithm.
Right.
And then his paper in 1997 called Polynomial Time Algorithms for Prime Factorization and Discrete Logarithms on a Quantum Computer.
Okay.
It was groundbreaking. It laid out the blueprint for breaking encryption using quantum computers.
So this has been out there for almost 3 decades now.
Yeah.
And Schneppat's essay is kind of saying, like, we're getting closer to the point where this could become a reality.
Precisely. And understanding the science behind it helps to grasp the urgency. At the heart of Shor's algorithm is something called the quantum Fourier transform, or QFT.
Okay, here's where it gets really interesting. Yeah. QFT sounds kind of intimidating, I'll admit.
I can understand that.
Can you break it down for us?
So imagine you're trying to find a specific frequency within a really complex musical chord.
Got it.
The QFT is like a tool that lets you isolate and identify that frequency much faster than trying to listen for it by ear.
Right.
In Shor's algorithm, the QFT helps find patterns in numbers that classical computers just can't detect efficiently.
So the QFT is like a cheat code for finding the weak spot in a large number.
That's a great way to put it.
Allowing Shor's algorithm to break it down into its prime factors.
Exactly.
And those prime factors are the building blocks of modern encryption.
Right, and that's why Schnepphat is so concerned.
Yeah.
He argues that we're just not doing enough to prepare for the day when quantum computers can run Shor's algorithm effectively.
So let's walk through, like, the basic steps of this algorithm.
Sure.
Just to give our listener a better understanding of how this code breaking actually works.
Okay, so the first step is you pick a random number. Then, using the QFT, we determine the order of this number.
The order.
Yeah, think of it like figuring out how many times you need to rotate a shape to get it back to its original position.
Got it.
This order is like a crucial piece of the puzzle.
And the QFT makes finding this order much faster than, like, traditional methods.
Exactly. Classical computers would take forever
to
do what a quantum computer could do potentially in a fraction of the time.
Schnepphat really doesn't mince words when he describes the potential consequences.
No, he doesn't.
He talks about a cryptopocalypse.
Yeah.
If we're not prepared.
He definitely emphasizes the urgency of the situation.
Yeah.
And for good reason. The implications of Shor's algorithm go far beyond just theoretical possibilities. This is real-world stuff.
Yeah. Okay. So let's shift gears and talk about those implications.
Okay.
What are the real-world consequences if Shor's algorithm becomes a practical reality? What are the real-world consequences if Shor's algorithm becomes a practical reality?
I mean, the impact would be widespread, potentially devastating.
Right.
You know, everything we rely on encryption for.
Yeah.
Online banking, e-commerce.
Secure
communications, even national security. It could all be vulnerable.
It's like somebody suddenly having the ability to read all our private messages.
Yeah.
Access our bank accounts.
Exactly.
Even shut down critical infrastructure.
Yeah.
It's a chilling thought.
It is. And Jörg-Owe doesn't shy away from these potential scenarios in his essay.
Right.
He argues that we need to be prepared for the worst-case scenario.
Yeah.
Even if it seems far-fetched right now.
He also mentions the impact on blockchain technologies.
Oh, yeah.
Like Bitcoin.
Huge.
If someone could factor the large numbers used in blockchain security, couldn't they manipulate the entire system?
Absolutely. The integrity of blockchain relies on the assumption that those numbers are practically impossible to factor.
Right.
Shor's algorithm throws that assumption out the window.
So it's not just about protecting our personal data.
Right.
It's about the stability of entire financial systems.
It is.
It feels like we're teetering on the edge of a digital abyss here.
That's a dramatic way to put it.
Yeah.
But it captures the sense of urgency that Schneepat conveys.
Right.
He's not just trying to scare people, though.
Right.
He's advocating for action. He believes we can mitigate these risks if we start preparing now.
That brings us to the big question. What can we do?
Right.
Is there any hope in this potential cryptopocalypse?
Well, there is hope. It's not all doom and gloom.
Right.
The field of post-quantum cryptography is advancing rapidly.
Okay.
Researchers are developing new encryption methods that are resistant to attacks from both classical and quantum computers.
Okay, so let's dig into that a bit.
Yeah.
What exactly is post-quantum cryptography?
Yeah.
And is it like a silver bullet that will solve all our problems?
So post-quantum cryptography, or PQC,
Okay.
it's basically a new generation of cryptographic algorithms.
Got it.
Specifically designed to withstand attacks from quantum computers.
Okay.
It's not a single solution,
Right.
but a collection of different approaches.
Okay. Each with its own strengths and weaknesses.
So it's more like an arsenal of tools
Exactly.
that we can use to defend ourselves against this emerging threat.
Precisely. And Schneepat argues that a diversified approach to PQC is essential.
Makes sense.
We need to explore various methods
Yeah.
and implement them strategically,
Right.
depending on the specific application and level of security required.
But even with these new tools,
Yeah?
isn't the transition to a post-quantum world going to be a massive undertaking?
It will be a significant challenge, no doubt.
Especially for large organizations with complex systems.
Right. But Schneepat suggests a phased approach,
Okay.
starting with the most critical systems,
Right.
like those handling sensitive financial or personal data.
So prioritize the crown jewels,
Exactly.
the systems that would cause the most damage if compromised,
Right.
and then gradually work down the list implementing PQC as technology evolves.
Exactly. It's a marathon, not a sprint.
And it requires collaboration between experts in cybersecurity, cryptography, and quantum computing.
Speaking of collaboration, what role does research and development play in all of this?
Well,
What are the brightest minds working on right now?
one exciting area is the development of hybrid cryptographic systems.
Okay.
These systems combine classical and quantum-resistant algorithms,
Interesting.
offering a bridge during this transition period.
So kind of like a hybrid car,
Yeah,
blending the best of both worlds.
that's a great analogy.
We can leverage our existing infrastructure
Right.
while gradually integrating these new quantum-safe solutions.
It allows organizations to take a more measured approach,
Right.
mitigating risks while ensuring continuity.
This all sounds promising, but I have to ask,
Yeah.
just how close are we to seeing quantum computers that can actually run Shor's algorithm
Right.
and crack our codes?
Yeah.
Is this a threat we need to worry about right now?
That's the crucial question.
Yeah.
And Schneepat addresses it directly in his essay. While quantum computing is advancing rapidly,
Yeah.
we're still some way off from having large-scale, fault-tolerant quantum computers
Okay.
that pose an immediate threat to most encryption systems.
So we have some breathing room.
We do!
It's not like we're all going to wake up tomorrow
Right.
and find our digital lives in chaos.
Not quite, but we can't afford to be complacent.
Right.
Schneepat emphasizes the need for proactive planning and action.
Yeah.
The quantum threat is real,
Mhm.
and it's approaching faster than many realize.
Okay, so we've explored, the potential impact of Shor's algorithm.
Right.
And it's clear that this is like a serious threat.
Yeah.
But I'm also feeling a sense of cautious optimism
Okay.
after learning about post-quantum cryptography
Right.
and the steps we can take to prepare.
Yeah,
It seems like Jörg-Owe Schneepat is calling for like a balanced approach.
I think so.
Acknowledging the risks while also highlighting the potential solutions.
Absolutely. His essay is a call to action.
Yeah.
Not a prediction of inevitable doom.
Right.
He believes that we have the knowledge and the tools
Okay.
to navigate this transition to a post-quantum world successfully,
Right.
but it requires a collective effort.
So let's distill all of this down to some actionable takeaways for our listener.
Okay.
What can individuals and organizations do like today to start preparing for this quantum future?
So for individuals, I'd say awareness is key.
Okay.
Understanding the basics of quantum computing and its implications for cybersecurity
Right.
is a good first step.
Right.
Stay informed about developments in post-quantum cryptography.
Okay.
And be mindful of the security practices of the platforms and services you use.
It sounds like it's also a good time to review our own password hygiene.
Yeah,
And consider using password managers that offer post-quantum cryptography.
that's a great point. Strong passwords and multi-factor authentication will become even more critical in a post-quantum world.
And what about organizations? What steps can they take?
Yeah, so Schneepat outlines a clear roadmap for organizations. First, they need to take inventory of their current cryptographic systems
Uh-huh.
and identify potential vulnerabilities.
Got it.
Then they need to develop a plan for transitioning to quantum-safe solutions,
Right.
prioritizing their most critical systems.
He also stresses the importance of collaboration and knowledge sharing.
Huge.
This isn't something that any one organization or industry can solve on its own.
Exactly. We need a collective effort involving researchers, developers, policymakers, and industry leaders to ensure a smooth and secure transition to a post-quantum world.
It's a bit like preparing for a major storm.
Yeah.
We know it's coming, we have some time to prepare,
Right.
but we need to act decisively to minimize the potential damage.
That's a great analogy, and the good news is,
Yeah.
unlike a storm, we have some control over how we prepare for this quantum future.
Right.
By taking the right steps now, we can mitigate the risks and ensure that our digital world remains secure.
Well, I think we've covered a lot of ground in this deep dive. We've explored the science behind Shor's algorithm, the potential threats it poses,
Right.
and the solutions that are being developed.
Yeah.
Most importantly, we've highlighted the need for proactive planning and action.
I think the key takeaway for our listener is this.
Okay.
The quantum future is coming, and it's going to change the world as we know it. But we're not powerless.
Right.
By understanding the challenges and embracing the opportunities, we can shape this future in a way that benefits everyone.
That's a great note to end on.
Yeah.
So, dear listener, as you go forth into your day, we encourage you to continue exploring this fascinating topic. Stay curious, stay informed, and stay engaged in the conversation about quantum computing and its impact on our world. Thanks for joining us on this deep dive.